Hi everyone. In this video, I would like to talk about one interesting project I actually stumbled, I would say by chance. It's about using a Kubernetes cluster to build another Kubernetes cluster. And if you're like me, I was thinking that, okay, what are the pros and cons of this kind of deployment scenario? Uh, First of all, we have what we call the Cluster API project, right? That's the official upstream project by the Kubernetes community. So the Cluster API is it gives a set of CRDs, and then also they give some kind of like the way you could create worker nodes, right, on several cloud platforms, including private cloud like OpenStack and VMware and the likes. So k0smotron, I'm finding it a bit difficult to pronounce this, but then I would probably say maybe it's Cosmotron or whatever. So Cosmotron is an example of a software that can help you to have that kind of deployment, whereby you first of all have what we call like a management Kubernetes cluster or a base Kubernetes cluster, whatever you can call that cluster, right? And then from that cluster, you now create, first of all, create the Kubernetes control plane. So the Kubernetes control plane, instead of them running on virtual machines, then they will be running as pods, right? And then from that pod, then you can now create some kind of token so that you can use it to initialize uh, another set of machine. And those worker nodes machines could be VMs or they could be bare metal or as the case may be. The reason why I got interested in this project was the simplicity, right? It's very, very easy to bring up, but then take note that it's being powered by k0s, right? So it's a stripped down, very light version of a Kubernetes distribution, right? It's lightweight. So uh, if it's something that you want to make use of, it's like K3s. If you are used to K3s, you have a feel of what k0s is, right? So if your need is to have a very lightweight Kubernetes cluster, then this might be a solution for you. But take note, one of the things you have to look at is once you begin to have Kubernetes in Kubernetes, then you need to be looking at, okay, what happens to this first Kubernetes cluster? Yeah, so not that it's a disadvantage, so to say, but you need to pay close attention to it because that's where your control plane pods will be running. So if anything happens to this cluster, then ultimately all the remaining worker nodes will be in limbo, right? So you have to this must be like an high availability cluster, right? And you must test the what do you call it, the what can I say? You need to test the backup and restore it just in case something happens to this cluster. And then when you recover it, how does it behave in terms of the cluster state of the second what can I maybe the child Kubernetes cluster. So it has its own advantages and disadvantages depending on how you look at it and depending on your use case. I mean, this can further be integrated to something like GitOps, right? Whereby you could just be creating your Kubernetes cluster right from your Git repo. You do a Git push, and then this go ahead to create what do you call it a Kubernetes cluster in within that uh, parent Kubernetes environment, and even your worker node also can be created via GitOps. For instance, you could make use of Terraform, right? Currently, we have a lot of uh, solutions for Terraform within Kubernetes also. You could actually create remote machines, right, via Terraform in Kubernetes. So we have controllers that can do that. So with that, you can have a full end-to-end GitOps architecture. So let's just see how this can be done. And then I noticed that also they are making some work to like maybe uh, be upstream compliant with the a cluster API. I see some commits here that shows, yeah, so if you see CAPI, CAPI stands for Cluster API. So I've not tried it with the CAPI, so I don't know the extent of the implementation using it via the CAPI implementation or the CRT. So first of all, what you do is you do your normal install. This, if you check it, you have a lot of RBACs, and then you have the CRLDs, and then once you create it, it will create a custom resource definition that is called cluster, right? So once this is created, then this controller or operator will pick it up, and then will create a it will create a pod just for the control plane. So let's see how this will be done. So currently I have a Kubernetes cluster. So this is my main, this is the Kubernetes cluster I'll be using to create the other Kubernetes cluster, right? So if you see, so if we paste this, we'll actually see then it goes ahead to create a namespace. You see it's called Cosmotron. I hope the pronunciation is correct. But then let's see what's in that namespace. So the reason why it was a bit fast because I already have I pulled the images. I already did a test run, so it's a little bit fast. So let's see if we are creating a cluster. So yeah, we can just create one in we could create one in the default namespace. So it is looking for, so let's paste this, and then let's remove the namespace. I'll be using the default namespace. Okay, so call it that, and then we come here, and so if we do a kubectl get cluster, sure, we see it as a cluster, but then if we see the get pods, we'll see that there is a dedicated pod for that. So this pod will be used as a control plane, right? So when I mean the control plane, it will have the etcd controllers and all the likes, right? And the kube API server. So so this might take a while, but let's go back to, so once you do that, then you need to exec into this pod, and then to create a token, right? So let's prepare this command also. So yeah, we are not running namespace, and then yeah, so we need to get the name of the pod. Essentially, you are executing into it, and then we do that. So if once that's up, we can do that. So let's see if the pod is up. Okay, so that means the API server is up. The control plane is up. So let's go ahead to, so we have a, yeah, okay. So yeah, we need to add a dash here. Okay, so we have a token created for a worker, right? So what we need to do next is I have another virtual machine. So you see here that I don't have the KOS binary yet. So what we can do is we can go to the we can go here and then do look at the installation quick guide and see how to install the binary. So do this. So by default, I think this is 1.27. Yeah, so it's picking the latest version. So if we do a which KOS flow, we see that it's there. So what we need to do is let me remove the file I have. So I can copy this token then before that also we could let's log in into the pod, because it's better to run the, so it will exec. So we're in the control plane pod. What you can do is use this kubectl get node. Take note, before we use the kubectl, we are using the k0s binary. So we see that we do not have any node yet currently. And if we see the pods, we see that it's still in pending because we don't have the any worker node currently. So to join this cluster this worker node to the control plane. So we see here, if you go under here, you will see add workers to a cluster, right? So we'll copy this and then come here and then choose the token file, right? And once we do that, we also need to do a k0 start. And then if we do the status, you can see if it's able to communicate with the control plane. So you see that, okay, it's saying that the role is worker, right? And then the Kube API program was successful through, right? So, and it's able to, the last try it did, there were no errors. So if we come back here and we do a get node, we should, so we see that this is it's actually also picking our host name here. You can see here is eben k0x worker. So after a while, let's see the get pods. So we see that the kube proxy is coming up, and then they are making use of kube router for the CNI. So most likely there must still be some other way to customize some of these options, maybe in the choice of CNIs or stuff like that. So if we do, we can see that the node is actually ready. Okay, so we see here that the remote stuff is, I'm running a Fedora VM, and then this is the IP address. We also confirm that that's the IP address to show that we're in that particular VM. So we can see here that, yes, so it's .17. So that's the basic thing on how to just simply create a Kubernetes in a Kubernetes cluster, right? So like I said, this may not be the need for everyone, but you need to do your, check make your research properly to make sure that it is something that meets your need, especially if you want a lightweight Kubernetes cluster. To also further just try, let's run a test pod here. So we do run test, then we add the image and just give it nginx. So the pod is created. So let's do the get pod. So it's in container creating. Also take note that you can also export your kube config, and you don't need to come into this pod to be running your kubectl. So you can also find that in the documentation. So we see that the pod is actually running. So if we exec into the pod, that's test. And then we do a call just to make sure everything is running smooth. So we see we can actually call the localhost on the nginx. So now look at the way it is. I first of all exec into this pod, and from this pod, I was able to exec into another pod, so to say. So it's kind of interesting, right? So one other thing to take note is that if you see here that you do get pods, how is the worker node be able to communicate back to this control plane port? It's because it actually creates a node port service type. So you see here, this is a node port service type, and then you see that actually the token has all the details of this. So with the node port, the worker node is able to communicate directly with the with the with the with the control plane port. So you could, I mean, we can also describe the service just to see what are the endpoints. So we see here that the endpoint is 71.12, and if you do a get port minus row wide, so we see that it actually matches the control plane port that we are running. We are using to create this cluster. So I hope this has been interesting. And sorry, one other thing is you should take note. For instance, in Fedora, you need to make sure that your uh, you need to open your firewall. If you don't do that, then most likely the for instance, kubeexec may not work. So you need to open the 10250 port. So that's the kubelet TCP port. So you need to do that. Let me see if I can get that in my history. So this was the command I actually ran to open up that port, right? So if you don't do that, something like your kubeexec may not work from the pods may be, I mean, they will actually go into running state. But then when you want to do the exec, because the exec goes through the kube API server, then all the way down to the kubelet TCP port. So that's one thing that you need to take note. So it's a fun project will be using a GitHub solution, right, to do the lifecycle, I mean, the end-to-end deployment for this. For instance, the actual creation of the control plane ports and also the worker nodes. So like I said, this worker node can be spun up by Terraform, right? And that Terraform can actually run as a controller in Kubernetes also. And with that, you'll be able to shift everything and make your source of truth entirely to be in Git. And then, like, don't forget, like I said, the parent Kubernetes cluster needs to be actually be HA, and you should test the recovery options to make, I mean, to the backup and recovery, especially when there is a problem. But another thing that we can take note of is, I believe this is also a stateful set. So so it's deployed as a stateful set. So essentially, if this I've not taken note of it, but if you could have like a PVC backend or whatever stuff for the whole cluster, right? Then that if that PVC is not affected, most likely if this port comes back up, then you can get your cluster state back. I'm not sure of that yet, so but it's a project I think is worth checking. So if this has been interesting for you, I implore you to subscribe and click the like button, and also share with those who might this might be useful to. Thanks for watching, and see you in the next one.